after John discovered that, you know, that I was capable to make the same machine. I mean, John worked on this for years. And we would talk about what could be done with this machine at night, but we would talk about other things too, like at the time we were working on the gravity field generators with Tom Bearden and stuff like that, and they were all friends. You know, all these people were friends. And we were talking about, he'd always say, well, come to my lab. You know, and then there'd be always something new in his lab. I mean, it was totally, you know, and we'd be talking about it at this coffee shop. And there were three of us involved. There was Steve Worth, John Sajak, and myself. We were all involved. However, Steve never made this machine. Steve knew how to operate it, but he never actually made that machine. I made the machine. Well, what actually happened was, and Tony asked this question, is I was giving a demonstration and people were laughing about, that doesn't do anything, that's just all crap, they were saying, right? And so I went over to the sink and I got my hands wet and I turned the machine on and I was sprinkling water on the plate, and this is what's known as the plate, but without the pitcher, without the witness. And I was just sprinkling the water on the plate. Well, I was sprinkling the water that came out of the sink from that building.
Yeah.
See, everything has a signature no matter where it comes from. And so I was sprinkling it like this, and everybody was laughing away. And pretty soon, there was one hell of a storm, Pat. I mean, it just flooded the place. The drops were huge. You know, there was a guy bringing an amplifier that I was supposed to repair for him, and he says, hey, let me ask you a question, John. He goes, why is it just raining here and nowhere else? And of course, I didn't give him an answer, and the laughter stopped. And everybody was seriously in trouble at that point in time because this rain didn't let up until I shut the machine off. And then it quit. And of course,
wasn't it coming down the air conditioning duct?
It was coming down the air conditioning ducts. It was coming, the roof was a flat roof, if that tells you something. It was flooded. It was coming over the overspills.
Yeah.
In other words, it couldn't get down the drains fast enough. It was coming out over the top. And I'm probably lucky that it didn't collapse the Sylmar facility.
Yeah.
You know, but I can tell you one thing. The people that were involved with me never laughed again about it. And they didn't want anything to do with it. And so, I'll finish the story with what I did with the machine. I sold it to Pete Kelly. And Pete Kelly had heard, because Rhonda had told Tom Bearden that, yep, that's exactly what John did, and it just rained like hell, she said. She said, and he had a customer coming. And the customer says, why is it just raining here? What's going on here? What is it? It just came out of nowhere right here. And of course I didn't answer that question, and she didn't answer the question, and nobody standing in the building. They just sort of turned around and went the other way, right? And just like, well, this must be a fluke, right? And what I did was later on, I was destitute, didn't have any money. And Pete Kelly says, do you want to sell the machine? And I said, yeah, I'll take $500 for the machine. So I packed up the machine and sold it to him. And Tom Bearden called me up about 3 weeks later after Pete Kelly had gotten that machine, and he says, you know, he goes, Pete did the same thing that you did, and a lightning storm and the rain came out and beat the hell out of him. And it scared the hell out of him. And I said, oh, come on, Tom, and Tom says, no, John. He was so afraid of the machine after that he dug. He won't tell anybody where he disassembled it and buried the machine. So, and that was based on,
yeah,
the UKACO principle. Later on, I explored more. See, the thing is, when you don't put that battery in there, you have no shield. So it can come back on you.
Okay. That's what you meant when you mentioned
That's
earlier.
why I mentioned to everybody that you must, you must put this battery in there. It's a shield from the machine coming back on you. So I want to keep stressing the point that you don't get your fingerprints on this.
Mm-hmm.
Make sure everything's washed down with alcohol. And I don't know, Tony, can we get a close-up of the way the plate looks with...
I have a question. I don't know about the technical side of it, but so why have you built this machine now?
Well, to figure out exactly how this one worked.
Okay.
Because now later on in time, our sophistication in technology allows us to get things like spectrum analyzers, and we can really see how this works. So I wanted to put one together. I put two together. Mm-hmm. And they both run identical. And of course, the antenna screws in here.
Yeah.
And this is a modern case compared to what John had.
Right.
Now, he never mentioned, and this may be something that we all should think about on this machine. He never mentioned, why is it in a wood case?
Doesn't transmit? I don't know.
Was it he couldn't get a metal case to put it in? Or does the metal have something to do with the machine?
Mm.
See, you have to ask all these questions. Why did he build a metal case and a plexiglass front panel?
He built a wooden case.
Yeah, he built a wooden case.
Right.
Because it actually looks more like an old radio, doesn't it?
I think this is because it has the look of an old radio. And also, you notice this?
You can lock it.
He locked them so the farmers couldn't get in them.
Okay.
In other words, they'd have to tear his whole case apart, and then he'd know that they got in it.
But he could have riveted this one.
He could have done a lot of things, but there's reasons and there's questions that John Sajeka never answered about any of this. I mean, this is stuff you would just go to the lumber yard and you'd get these, looks like a 3/4 by 8.
Yeah.
And then it's like he's built a box out of this. And because it's tubes, he's drilled all these holes.
Right.
Because of the heat. And you can see he didn't have a pattern. So he was experimenting with all this.
He wasn't a master...
No, he was not. He wasn't a master cabinet maker, and I'm sure he could have had somebody done a much better box than that. But why bother? I mean, it was an experiment with John, and he was interested to see if the machine was actually going to treat all these fields.
Yeah.
And they did. They worked.
Actually, John, I was thinking, why did he use a wooden box? Do you think? Why not use a metal one? They had metal ones back then.
Well.
Yeah, but they were back then. When are you talking about? 60s or 70s?
70s, yeah.
I would have thought the metal box, a custom metal box, would be pretty expensive, and to put together a wooden box like that, the local cabinet maker could have probably done it. I don't know. What do you think, John?
It's always puzzled me why they all were in wooden boxes.
Uh-huh.
All right. Now here's a thing that is kind of interesting too. even the UKACO device was in a wooden box.
And that wasn't him at all.
Right. Right. I mean, they had the money. These guys were professors when they were doing the experiments, and they had the school behind them and everything, and they had the agricultural department that they were dealing with. So I have no idea, except that what I said. If you look at the box, it's wood. There's no distinct pattern to drilling any of these holes. If you look at it,
They're all off.
it's got a key lock, right? It's like they were drilled downhill.
Yeah.
And the chassis that's in there is something you would get from, say, Bud box. And it doesn't even seem to be important in a way. And what's even funnier is these parts,
Yeah.
the resistors, they're all like 10 and 20%. They're not even on value. So, this one could be 470K, and this one could be 475.1K. So it seems to be none of this is important. You don't need any 1% resistors or anything. Definitely the capacitors are like 20% or 30% when I took this one apart. And it's just, it doesn't make any difference where the wires are going or anything. There's nothing in a nice, neat wire loom or anything like. It's just like this is running from this point A to point B, and basically underneath. And I noticed that about the UKACO machine too. Basically underneath, he's got this chassis, right? And he's got a tube here, and he's got a tube here, and a tube here, and a tube here, and a tube here, right? And the sockets underneath, right, with their pins, right? It's like he's got a resistor that's 20% soldered over here, right, like this, and then he's got some kind of tabs here, right, and he's got this one stretched, to this point, and then this point stretched over to this point. So it's like point-to-point wiring.
Yeah.
Right? And there's no procedure to any of it. There's no neatness to it or anything. It's just put together, and this is the way it works, and that's it. I mean, so I have no idea why, he wouldn't invest in a metal cabinet, except that maybe he didn't have the funds to do that.
Yeah.
He probably did this out of his own money.
Yeah.
And he developed something that worked, and then he says, well, I can just duplicate this one thing that works. And basically, when you look at his machines, they all work the same. It's got the same meters. It's got the same switches, the same plugs. These are guitar plugs.
Yeah. The handle is like
It handles the guitar handle.
briefcase handle or something, yeah.
Yeah, it's just...
Yeah.
And the key lock is something you go down to the local hardware store and
So
buy them out,
Yeah,
right?
maybe he basically scavenged parts.
Well, there's a lot of old TV parts in there, that I noticed right away, like the tube's a 6AC7, and that's a metal tube. So they're these, tubes that are metal like this. They're a metal tube.
Okay.
They're not a glass tube. They're a metal shielded tube, but they got real high gain. And I think that's why he used them where the UKACO didn't use that. The UKACO used a 6SJ.
Is that a metal tube as well? Or?
Yeah, it was a metal tube.
Yeah.
So you've seen the UKACO machine?
Oh, yeah.
Yeah.
I have pictures.
Yeah.
I not only have pictures, I have the full drawings to of a UKACO machine because I actually had a UKACO machine here to take apart and analyze.
What happened to it?
Gave it back.
Oh, okay.
And then I was given all the prints. And that machine now, on the other hand, was laid out nice and neat.
Yeah. Well, Pat makes a good point also. This is serial number 114 that I was given.
This one.
Yeah. So there was 113 that went before it,
Maybe.
Yeah.
which is a lot. So production costs would have been a lot cheaper with a cabinet maker knocking out wood cabinets for him than buying a whole bunch of, back then, custom-made.
Right, and this is like it's routed out, Tony, out of the piece of wood with a hand router.
Right.
And it raises an interesting question because when we were with Ronnie, he maybe had 4 or 5 there in the house, and there was a few more scattered around, but you're still about 100 short.
Yeah, where are they?
Yeah.
And John had one in California with him.
Yeah, but his was kind of a custom-built one.
Well, it was a lot better looking
Yeah.
than this.
You said he had one that was smaller than this.
Yeah, it was a little bit smaller than this. And that's right, where are the rest of them? Where did they go?
Yeah.
I mean, because I doubt that it started at serial number 100.
No.
Yeah.
No, John would have started 00 and then 01, 02, 03.
Right.
Yeah.
Yeah, that's the way John would have done it
Because the more he got out there, the more money he'd get.
right, these were leased.
Yeah.
These were never for sale,
Right.
right?
Right.
And none of these are for sale.
So,
You know,
okay, so why did you build these?
to find out with a spectrum analyzer exactly what was going on
So
with it.
it's a research project.
Yeah, and I actually have the picture that I took out the spectrum analyzer, and you know, I was trying to be with the people, trying to tell them, you know, that you start out with this frequency, but when you look at the actual frequencies, you know, make it a little more detailed. You know, they've got a fundamental here and a fundamental here and a fundamental over here, and these are all, you know, what John was tuning to get to the wave that sort of looked like that,
Right.
which was a burning feather, basically. You know, and all the frequencies are in this burning feather. I mean, so. You know, that's something, I mean, this is so typical because not only is this thing working on sidebands, the Rife machine works the same way on sidebands. And in fact, a bunch of, even the Abrams machine, the medical machines, all work with these sidebands.
Yeah.
And they all got some fundamental carrier frequency, you know, that they got. And I mean, that's for another time, but basically they're all doing the same thing that works in the biological realm.
Right.
You know, so even, like I said, the Abrams machine was nothing more than a pendulum that, what they called a tick-tock oscillator, wasn't even invented by Abrams. You know, and the thing about that one is that it generates these pulses, and then there's a Tesla coil in it, right, that isn't even really hooked to anything. And it's generating these spikes and waves.
Sounds like Daniel or something.
Well, it sounds like, you know.
Yeah.
And most people, like I said, the ones that were around when I was goofing around with John with this, they just laughed until it rained. And then they didn't laugh anymore.
Right.
Pete Kelly didn't laugh after that. He just buried it. Actually, I heard that he smashed it up in a million pieces, dug a 6-foot hole, and threw the machine in it. That's what Tom said to me. I said, "You got to be kidding me! Destroyed my machine?" And he goes, but you know something about that? He got really sick after that. And the other thing that I find interesting, and I really, don't want to make a conspiracy theory out of it, is why would a tornado come out of nowhere if there's these machines missing?
Right.
Tony says there's these machines that they don't have.
Well, all we know is this is number 114.
Well, we also know that we saw at Lonnie's house 4 or 5.
Right. He said he had 4 or 5,
Yeah.
yeah.
But where are the others?
Well, he said some of the farmers kept them and hadn't turned them back in, and
Remember, they were never sold, Pat. They were leased.
Right.
Yeah.
Property of John H. Sadeka.
Yeah.
Yeah. So,
Strange.
that's about what I can tell you about the case and the box, and it just seems strange to me that that this is built like an old-time radio.
Yeah.
It's even wired like an old-time radio when you get in there. And so that's something to be considered.
Yeah.
Yeah.
And if you notice, even the antenna is insulated
Oh, is it? Okay.
from the wood box.
Yeah.
Well, that would make sense.
Well, isn't the wooden thing...
I don't know, you could have mounted this antenna. It's got a
I
mount.
thought wood was sort of an insulator anyway.
Well,
No?
it is. But the way he's got this in here, it's
Yeah.
maybe that the antenna mount was too thin to go through this, 3/4 of an inch. And so he probably drilled a bigger hole and put this plate in here and then mounted it in plastic, because this looks like it's replaceable.
Yeah.
In other words, you just take it out and replace it when somebody snaps it off.
Yeah, somebody will snap it off.
Yeah.
You gotta,
And what's funny, if you look at this, they don't even sell this kind of antenna. Keeps going and going anymore. You have to use a whip now if you're going to do it.
I know we had plenty of cars with antennas like that.
Well, early on.
Yeah.
Right.
Maybe that is a car's antenna.
No, this is like a shortwave radio antenna. It's got like 9 sections to it
yeah,
here.
we had one on the Shorrock.
On the what?
Shorrock.
Oh, yeah.
Yeah, so.
John, would you mind recapping a little bit what we were just discussing?
Yeah, Pat, I'll get as close as I can to what the film was about.
Okay.
And I'll start out with the basic theory, which is the symbol for an IC.
An IC is what?
IC,
Okay.
which is an integrated circuit. Now, Sadeka, I'm going to point this out, Sadeka did not believe that it could be done solid state wise. For the simple fact is, if you look at the solid state transistor and you look at the tube, one uses space charges and one doesn't. In other words, the charges that come from the cathode, they always assume that those are space charges. And John used to talk a lot about dark rays and things like that that came off the back of TV picture tubes and different things. But anyway, to give the example, the IC, to make this machine function, once again, we have a witness on a plate, and let's just say that that's a tree that's infested in South Africa, someplace like that. And that tree has a beetle infestation. So, if I do Africa, we'll just assume that I did Africa here,
Yeah.
right? And that tree is located right here. And I get a picture of that tree, a Polaroid picture of that tree, and I get a ground sample. and I put the dirt sample on the pitcher, and I get the beetle. And this is a dead beetle, but it's that species.
Right.
And I put that on there, and then I put the insecticide on here in a vial. Meanwhile, warning again, you don't touch this
Right.
with your hand. You know, everything has got alcohol. You have to alcohol everything, make sure you have no fingerprints on it. Okay, so what's going to happen, and this gain is 100,000. This self-oscillates between this point and this point. So, the plate is a copper plate, and the pitcher is located on the plate. And I'll get into a little bit here in a minute. But this is some gain that's selected.
Okay.
All right, and so what starts happening is it starts to oscillate in between these points, and it grows. Once again, it keeps growing like this. And see, and this keeps going out and out and out and out and out. It takes a little bit of time for this to happen. But now you can see that it's reached this point here with its frequencies in here.
Right.
You know, that's harmonics of the master oscillating frequency, which is actually a fundamental frequency here. And we'll show you a picture of the spectrum analyzer so that everybody can see that. But anyway, that's basically how it operates, is it self-oscillates and it keeps building itself like this. And since John Sajeka used it for agriculture, he called it a bioharmonics machine because of the harmonics that were generated by the tube stages in the machine. All right? So, let's recap just a little bit further. You need some selected gain at multiple stages. He believed that you couldn't do it with integrated circuits or solid state because it just didn't give you the same wave shapes.
So hold on a minute, because I've got a few questions. So since it's spreading out like that, wouldn't it affect everything that falls within those almost parallel lines?
No. It's transmitting the same signal.
Okay.
In all these lines. But what it's doing is seeking out this.
Okay. Yeah.
It's seeking out this witness.
Okay. So when the first one has passed the target, another one is coming right behind it?
Yes.
Yeah, okay.
Yeah, so it's multiple. Mm-hmm. It's like an ocean. It's like throwing a rock in a lake and it puts out the rings. Right. It puts out these waves till it hits something.
Right.
Now here's the thing. It's hit this target. So there's a bounce back. Okay. There's a bounce back. So now if there's a rock here and this ring hits this, right, then you see another wave start to come back.
Yeah, I've seen that on the harbor or something.
Right, exactly.
Yeah.
So
reflective wave.
Yeah, reflective wave. So it's doing this, so you must take precaution in what John Sajeka was saying, and it must have some form of shield.
Okay, now I see what you're saying, yeah.
Right. And so this ground would be isolated.
Yeah.
And then the battery would be put in this position. Mm-hmm. You see what I'm saying? Because we know the negative of the battery. It's almost like a reverse polarity
Yeah.
that keeps the bounce back from coming back to the witness, because then it's interference after that, if the bounce back comes back.
Yeah. Okay.
All right, so now, do you understand that
Right,
part of
now
it,
I
Matt?
do, yeah.
Okay. But once again, I'm going to stress this. That when handling this machine, use gloves.
Yeah.
And make sure that you clean the gloves with alcohol, and make sure that the witness is wiped down with alcohol.
Right.
Make sure none of your fingerprints are on this machine, on the witness. Okay, so let's just for a second here go back to John's machine, which is this machine right here. And if you look closely, you can see that this tube here, there's numbers on these tubes. You can see that?
Yep.
And these numbers are the tubes John selected to go in each stage, and he scoped these
Okay.
so that he could get the side bands that he wanted, the bands in the frequencies. So we've got 1 stage, 2 stage, 3 stage, 4 stage, and the rectifier tube,
Yeah.
which now would be solid state. This is not important. What's important is the gain of these stages and how they're working. And then you can see that this wire here comes out to this antenna.
Yeah.
Right. And this is like 53 inches long. So this antenna is 53 inches. So once again, John's stages are these tubes. Now remember that in his stages, this ground is isolated, because between these grounds are all going to tie together in the stages.
Yeah. Yeah.
And between this part of the ground is the battery. And that becomes earth ground. All right?
What is the battery there for?
A shield.
Okay.
So that
yeah.
you don't get
Yeah,
any
yeah.
feedback
That's perfect,
from the
yeah.
from where the target is.
Yeah. Okay.
All right. So he has very conveniently selected R1 and R2 to be some specific gain. So this was, I think, in the machine, this was 270K. And this was 30 ohms. So that divided by that will give you the gain of that stage. All right, and then he's coupled these stages like this. Now it's an identical stage, Pat. These are identical stages. The screen he has just tied up to the B plus line, which is positive voltage. And then this screen here, he's tied back down to the cathode, which turns this into something that's equivalent to a 6L6 tube, but you can't use a 6L6 tube because it does not have the gain of the tube that John Sajeka chose, which was the 6CL6, I think, here. Let me make sure that's what it was. Whatever, the tube is close enough, 6CL6, 6AC7. There are a few tubes, 6SJ7, that you could use in here, so I just put 2. And you tie them this way. And then, of course, he's done the same thing again in the next stage. Tied to that point. This one tied to here. This one tied back up to the line. And then this grid is tied here, and he's also put a resistor in the grid line of 1 meg, so that you cannot, so it forces a negative voltage on the tube. And so then when again, this is your witness, into the first grid. And then he's tied a 1 meg resistor here, ground. And so then, well, I'm just going to do 2 stages.
Okay, but he did 4, right?
He did 4 stages, right. And let's say this stage has 50,000 gain. This 50,000 gain then is multiplied by this 50,000 gain times the next 50,000, and that's
the billions before you know it.
Well, you're up there in an infinite number,
right?
To where it's oscillating all the time,
right?
So then what he's done is, out of this plate here, he has capacitively coupled that to a 53-inch antenna. And that antenna is pulled up, see, for 53 inches. So we just, and basically you can set whatever you want here, you know, as far as the length goes. So you could actually tune it with the antenna if you wanted to.
Okay.
And it's swivelable. See, it's got a swivel. So you can move the antenna back, or you can move it forward. You can just do what you want to do with it. And these, during the 60s and 70s, were available everywhere. I mean, you could go to what was Radio Shack then. You could just go to any electronics store and get this antenna, which was 9 pullouts.
Right.
So basically then, what John has done with the tubes, remember these are heated cathode tubes, which means they have a filament voltage, so that's why you see the 2 switches on the machine, the red and the green. And something convenient that he did also was he broke this line where the battery is. So we just crossed this out for a minute. We pull this wire over here, and we put a switch here. And he called that switch spray. So when he turns this on, in the power supply there's a current meter. And when you turn the spray switch on, it completes the circuit. And the current goes up to, say, 25 to 100 milliamps. And that indicates that the spray is on with the green light and that it's oscillating.
Okay.
So that's one thing to remember, is that he's got a meter in the front, and when you turn this, and this one says spray, and the other one says power, which is just lighting the filaments. And what he would do is he would let that run for about 10 or 15, maybe 20 minutes, and then turn the spray on. Because he wanted the tube stable, all the same heat range. And so that's basically how this machine operates. And then this will start its oscillation, right? And when it finds its target out here, there'll be a return wave in these bands.
Right.
And you don't want this return wave going back to the witness. So
Why not?
Because then it's contaminated.
Okay.
It's contaminated with frequencies you don't want.
Okay.
So he very conveniently said, I need something that matches elements. And that was a dry cell battery. Zinc, carbon, not alkaline, and not lead acid. So this must be a dry cell, and I'm going to put that down. Must be. That means the cheapest battery that's got zinc and carbon in it, and nothing more than that. And this battery does not power the units, and I don't want anybody getting the idea that this battery is going to power the unit, because it's not. It's just used basically as a shield. And it doesn't operate correctly without the shield. It may work and it may not work.
Okay.
You know, because I've run many experiments on this, and that battery's got to be in there.
Yeah.
To stop what's going on. And so, remember, this return wave, right, is blocked through the ground.
Yeah.
Because the witness and everything is on the ground. So that blocks the return wave through the grounding rod of this machine, which is here, which is in the earth. 5-foot rod. And so I think now that I've covered pretty much everything, Pat, unless you have some more questions.
Yeah, you said 5-foot rod in the ground?
Yeah, well, he always used a 5-foot copper rod.
Oh, and he just sunk it straight into the ground?
Yeah, an electrician's rod. He would go and, you know, go to the hardware store and get a grounding rod that they pound into the ground. California was pretty easy to pound into the ground.
Yeah.
Up here in Idaho, it's not real easy to pound into the ground because you're always going to hit a rock. You know, so, but you can lay out a wire. I'm pretty sure you could lay out a, you know, dig a trench and lay out a 5-foot ground. My early machines never used the ground, and that's how I found out that you pretty much want to be protected with John's shield here, because, you know, the storm that I created, I really didn't want to be in.
Yeah.
And the one that Pete Kelly created, I'm sure he didn't want to be in either.
Right.
But
So those occurred because...
there was no shield.
Right.
It just came right back on itself.
Right.
And then the minute I put the battery in it, things changed.
Yeah.
Because I remember John's comment one day. He was walking in the garage and he was going,
Yeah.
shaking his hand. And he was going, I'm going to tell you. He says, where's your battery? I said, what? Where's your battery? That's what I need a battery for. So you need to protect this machine. It doesn't operate correctly without the battery. Now, another thing that's kind of funny too was a comment that he made about the battery. Now, his brother said the battery has to be good. Has to have something in it. And I really don't know the reason why his brother said that, because I ran the machine with a bad battery and a good battery. And the one thing I did notice, that you lose a little bit of current in this meter by putting this battery in there. But I don't think that's an important thing. In other words, because the tubes can only take 300 volts maximum anyway. And there is, you know, voltage here. So between ground, say earth ground, and here, you will get shocked if you touch the ground. And it'll be a pretty good size shock. It'll be a 300 volt shock. You know, there'll be no current in it, so you're not going to die or anything like, well, you might if you have a pacemaker, but the point is that you definitely don't want to touch the ground in the thing when the machine's in operation. You can go and you can do this with the antenna and listen to it play the musical sound when it'll go bzzz, bzzz, and you know then that the machine is operating, because that's the first thing John Sajeka did when he said, run your machine and turn it on.
Yeah.
Is he went right to the antenna and he grabbed it and he went like this. And he just got this look on his face like, oh my God. An unexperienced person with a bioharmonics.
What have I unleashed here?
Yeah, what have I done here? But what I want to point out to everybody is we released everything in other DVDs too. We've released the SG, SSG, we have released other DVDs, but we've released everything that we could possibly release.
Yeah.
You know, so people can learn whatever their science is.
Right.
And we're, you know, we've done more. They're just not released yet.
Yeah.
And, but I suggest that everybody get a series, and especially the Sajeka files. Because this is in the Sajeka files.
Yeah.
If the people would buy the Sajeka files, there's a lot of information. Like this is one of the devices that's in there.
Right, the UKACO.
The UKACO, and you can see it's only 2 stages. And it's definitely here.
Right.
And see, John Sajeka figured out you don't need this. You did not need this 8 Henry choke. You don't need this capacitor because of the wave shape he was looking for.
Okay.
And that's the difference in the machines. But you can see this one has 270K in the plate and 1.8K in the cathode. So if you divide that into that, you're going to get the gain of this stage. And then this gain is multiplied by this gain, and that's what's coming out of the antenna.
Yeah.
And Sajeka said, I need to have something that works immediately.
Yeah.
That doesn't take a long time and is weak. So John, you know, made more stages to the machine, which anybody could do, which drove his machine into infinity.
Right.
So do you feel like that you understand this machine a little bit?
Now that we've done the recap, yeah. I still had some questions before, but now you've gone over it again. It's clarified a lot in my mind.
I have another question. Do you sort of reach the point of diminishing returns with the number of stages? Like if you added 5 more stages to where you have 10 stages, would that, you know, do anything?
Well, there's only so much you can multiply.
Yeah.
Right.
And then it's just...
When you're already at infinity, then...
Yeah, you don't need to go anything more than 2 to 5 stages. I mean, if you're just an early experimenter, I would probably buy the Sajeka files and build this device to experiment with. However, I'm going to make that warning again. Do not touch the plate. Make sure the plate's clean.
Yeah.
Make sure that your skin oils and everything that you do is off that plate when you goof around with trying to take care of beetles or spiders or something like that.
Right.
Just make sure, because this will come back on you.
Yeah. Even if you put the shield in there?
Oh yeah, it would, yeah, because if you put your fingerprint on here, and say this witness is over here in Africa,
Right.
and now you got your fingerprints all over this plate, and you got DDT on there, and you got a soil sample, and you got all that, right? And you live over here, and it's going to come right to you too.
Okay. So it's going to find that?
It's going to find the witness.
Right. Okay.
You know, it's going to find the destination target.
Right.
The witness has already got your imprint on it.
Right.
That's unique to you.
Yeah.
The oils in your skin, your hair,
Right.
any of that's unique to you and not the other person.
Yeah.
So I think with that, I'm pretty much finished with this outside of maybe pointing out once again that he's got the very first stage and he's got it numbered, so he selected this tube for gain. And what John was doing here was actually matching all the gains of the tubes, because he's got a 105 here, and he's got 90 here, and he's got 89 here, and he's got 94 here. So he has selected these tubes to work in this circuit at these frequency ranges. And I'm not quite certain John ever owned a spectrum analyzer. There would, they didn't have the technology we got now. So he had to scope every one of these and look at it. And with that, that's pretty much what I wanted to say. Outside that, I'm telling everybody, just get the DVD so you understand all the technology.
Right.
If you start with the first DVD with the energy, you'll understand that the energy is different. And as you move up in DVDs, you're going to find more and more things, and then pretty soon this all becomes self-evident.
Yeah, it all becomes a part of the matrix.
It becomes the way that you're looking at the energy, because you remember you can't do anything with energy.
Right.
You can't destroy it. You can just move it to another form.
Yeah.
And that's basically what this whole series is about.
Yeah.
Is all these unique translations of energy.
Yeah.
And if you pay very close attention and you actually build the circuits and get things to operate, you'll see a whole new realm in energy. And with that, I think that's pretty much done.
Well, thank you. That's great.
Thanks, John.
All right.
Yeah.
I'll tell you, this thing is haunted. I can tell you that, because I've been in at night, and you wouldn't believe what you'd hear. A lot of whispering, things moving around, stuff. So I just don't come here at night. And I've been here several times in the dark. And I'm going to tell you right now, there is not just you here when you think you're here by yourself. So it's definitely haunted.
Was there any crime committed here?
No. But a lot of children were educated here. And you'll hear a lot of creaks and groans and whispering sounds and little voices here and there. I've many times heard that.
Children were born.
Yes, lots. Mostly children. Children's voices. So.